Friends, we have talked about pressure, volume and temperature. How to define them? In the interviews I have seen 90% of the students defining pressure as force per unit area. And 90% they are not to be selected because they are taking it very lightly. A student when defines force per unit area, next question I ask, let this be a cylinder and piston arrangement. Some gas is there and a force F is acting like this, where A is the area of cross section. Then the student says it is not F upon A. Then what it is? We have to take the normal component of the force on the given area. It is not just F upon A, we should always define as the normal component of the force per unit area. The 10% students who get selected, they talk like this. Next, what is a unit? That means we should know the unit of force and unit of area. Force is the rate of change of momentum. And momentum means mass into velocity. Rate means with respect to time. Mass kg velocity per unit time shall become meter per second, that means meter per second square. That means a mass of 1 kg subjected to an acceleration of 1 meter per second square. This force term was defined by Newton and hence is called as Newton. Wherever we will find the units kg meter per second square, we will try to replace it by Newton, which is normally written by the term capital N. Now my experience is about area. If I ask a student to define area, he says how area has to be defined. Area is the term which is being used. Area is the space occupied in 2 dimensions. Space occupied in 1 dimension is called as length. Space occupied in 3 dimensions shall be called as volume. Fundamental unit of length being meter, area shall be in terms of meter square. So the unit of pressure shall become Newton per meter square. Earlier, when science was not properly developed, somebody doing very little work, he was becoming famous. For example, just the term force, mass and acceleration, Newton became popular because he gave this concept. And for the pressure, Newton per meter square, this concept was given by Mr. Pascal. And to get the popularity, instead of using the term Newton per meter square, he suggested use the term PA. So, my dear friends, pressure now onwards will be writing in Pascal, Newton per meter square, kilopascal, kilonewton per meter square. Then the question arises, any other term with which the pressure is stated? That is bar. What is 1 bar? 10 raised to the power 5 Newton per meter square. 10 raised to the power 5 Pascal. The term is used as 1 bar. Now the next question is, what is standard atmospheric pressure? Some students say 1 bar is the atmospheric pressure. But this is not the case. This is for just simplicity. We assume it to be 1 bar. How to calculate this pressure? Some students say 1.01325 bar. Then I ask, from where do you get this figure? Some students respond that this is the value given in the books, so they remember it. In the interviews to B.Tech, M.Tech and PhD candidates, many times I have asked this question. So far, no student has ever been able to derive it during the course of interview. Many students try, I provide them calculator, we get some other figures and then they say nearly it is same. I say when it is nearly same, that value should have been given in the books. Why this value is given? And some students, they dare, after the interviews, they come and ask, sir, how do you get this figure? P is equal to rho G H. And then many candidates claim that they have also used this figure. Rho in kg per cubic meter, g meter per second square, h the height of the mercury column in terms of meters. Kg meter per second square is Newton. This is meter square, it becomes Newton per meter square. So we are getting units all right. Just writing this expression rho gh is not enough. H is in terms of mercury column, so density also we have to write for mercury. And the density of mercury is 13.5951 times heavier than water. And for water, it is 10 raised to power 3 kg per cubic meter. If you write down the value of 13.6, you are not going to get the answer. 13.6 used to be the round up figure. Next is G, which is 9.80665 meter per second square. If you write 9.81, that holds good for your calculation purposes otherwise. When you talk of fundamentally, the value of G happens to be 9.80665. 9.81 is the round off figure. Whereas when you are in 9th or 10th class, many times you have been taking the value of G as 10 meter per second square. That all is what is required. Now we are requiring the basic value of P, the standard atmospheric pressure. That means we must use the standard values. And then 0.76 meter of mercury column. Now you calculate this. And you will be getting 10132.5.01 Newton per meter square. Which is 1.01325 into 10 raised to power 5 Newton per meter square, which is 1.01325 bar. So, my dear friends, knowing the exact value of rho, knowing the exact value of G matters a lot. Knowing this will mean you get selected. Not knowing about this, that means you are getting rejected. There are some values which must be remembered for all the times to come. Any question, please? Now this pressure, small values very close to the atmospheric pressure, can be read with the help of the barometer. Values higher than that, in engineering, we measure with the help of pressure gauge. Pressure gauge indicates the pressure well within the system. And then atmospheric pressure is acting on it. So, we use a term called as absolute pressure, which is atmospheric pressure plus gauge pressure. Many times we have seen when we remove the given matter from the given system with the help of a pump and vacuum is created, gauge will indicate pressure lower than 0. And then the absolute pressure shall mean atmospheric pressure minus the gauge pressure. Thus, in all engineering applications, we will be using the term absolute pressure, which is atmospheric pressure, this value, plus minus gauge pressure. Plus value will be used when the gauge indicates above 0, and negative will be used when gauge indicates below 0. The next term used is volume.
So, one student is asking the significance of absolute pressure. Can you repeat that once again? Is that was a start?
I am having a cylinder to which I have put a pressure gauge, and gauge reads 5.2 bar. And the atmospheric pressure is 1 bar. The absolute pressure becomes atmospheric pressure 1 bar plus gauge pressure 6.2 bar. I am doing an experiment at a place, say Delhi, where atmospheric pressure is 1 bar. So that means all my calculations in the equation PV is equal to RT shall be done with the help of 6.2 bar. Whereas my friend is working at Srinagar, Kashmir. And in my specifications I had written pressure is of the system is 5.2 bar, atmospheric pressure is 1 bar, and he doesn't have the concept of absolute pressure. I asked him to provide similar conditions in Srinagar. There also he tries to maintain the pressure of 5.2 bar. Whereas the atmospheric pressure at Kashmir was 0.97 bar. Few meters above the mean sea level, pressure is reduced. Now the absolute pressure becomes 0.97 plus 5.2. .17 bar. Now the results what he is getting are different than what I was getting in Delhi. He is doing calculations a number of times, but things are coming out to be different. Atmospheric pressure has to be taken into account, which is acting over and above the given system. System pressure was 5.2, 1 was atmospheric pressure over it, absolute has become 6.2. Here it is 6.17, things will never be matching. To have the similar type of the activities, we are using the term not just the gauge pressure, but we are talking about the behavior of the surroundings where our given system is located. Hence, atmospheric pressure plays another role over the given system. When this atmospheric pressure was less by 0.03, he should have maintained this pressure to be higher by the same amount, 5.23, so that this should also have become 6.2, so that the systems are behaving identical. Hence, in the equation PV is equal to RT, the value of P which we are going to write should be the absolute pressure and not just the gauge pressure. I hope now it should be clear.
Thank you, sir. We got it. Please say thank you.
We were talking about the volume. Volume should be defined as the space occupied in 3 dimensions. Fundamental unit being length, area meter square, 3 dimensions L cube, that means meter cube. Whereas many times it may be given in terms of liters, centimeter cube, or simply cc. These values must be converted to meter cube and then to be used for the calculations. The conversions 1000 cc corresponds to 1 liter. You take milk of 1000 cc, that means it is 1 liter. And 1000 liters shall mean 1 cubic meter. No doubt these things are quite simple, but we are trying to revise the subject, and hence everything which comes into the picture must have been revised.
So two students have doubt. One is asking what is the difference between PSIG and PSIA.
PSI, this stands for pounds per square inch. In FES system, forces used to be pound force when area taken in square inch. Unit of pressure used to be PSI, pounds per square inch. If the term G is used, it shall mean gauge, and PSI shall mean pounds per square inch absolute. The standard atmospheric pressure, which I stated 1.01325 bar, corresponds to 14.69, which normally we take as 14.7 pounds per square inch. So PSI is for pounds per square inch, G for gauge, and A for absolute. This exact value is 14.696, which we take as 14.7. When you are going to the petrol pump for taking high pressure air for your vehicle, you tell him 28-28 कर दो, 25-25 कर दो. वो 25 क्या था? That was pound per square inch gauge. The gauge which he is using should read that value as gauge pressure in terms of pounds per square inch. This used to be in FES system. In MKS system, it used to be kg force per centimeter square. 1.0332 kgf per centimeter square corresponds to 14.696 pounds per square inch should correspond to 1.01325 bar. In our time, we used to study in FPS system. I graduated in the year 1966 when we had everything in terms of pounds per square inch. That year 66-67, from FPS we changed to MKS, and I started teaching in terms of kgf per centimeter square. By the time things were okay, we shifted to SI system, where it became in terms of bar, in terms of Newton per meter square, in terms of Pascal, kilopascal, kilonewton per meter square. So this is the old history, but as a student you are supposed to know these terms. So it is very good that somebody asked PSIG and PSIA. Pounds per square inch gauge, pounds per square inch absolute. I hope it is okay.
Yes, sir. And second question is, do all the devices measure the gauge pressure only, or can we also measure the absolute pressure
No.
directly?
Because instruments all which we are using, they are the gauges. They are reading the pressure of the system. And pressure of the system read with the help of any gauge is called as gauge pressure. No instrument shall read the absolute pressure. As no instrument reads the temperature in Kelvin, all instruments are reading either in Fahrenheit or in centigrade. The next fundamental property is the temperature. I have seen 99% of the students talking temperature as the degree of hotness or coldness, which always I say is the absurd definition of the temperature. Let us say in a room the temperature is 25 degrees centigrade. Outside temperature in summer is 40 degrees centigrade. And then 25 degrees centigrade is lower temperature, so it shall become degree of coldness. In winter, when outside temperature is 10 degrees centigrade, inside we are maintaining same 25 degrees centigrade, this 25 shall become hot with respect to 10 degrees centigrade. This 25 degrees centigrade is what? It is hot or cold? Why we are talking in terms of hotness or coldness? Why not we talk 25 in its own sense? Why should I say 25 is less than 40 and is more than 10? Why I should not have the technology to talk 25 in its own sense? Why to compare with 40 and 10? What is this 25? This is the thermal potential of the system. What for? Responsible for heat transfer. It is that potential to which heat will be added from 40. It is that from which heat will be rejected to 10. 25 remains as it is. The thermal potential of the system remains as it is. Hence, friends, have the clear concept. No one words, never try to use the term hotness or coldness. Use the term thermal potential of the system responsible for the heat transfer. Now the question arises, this thermal potential is with respect to what? That means what is the minimum temperature? I have defined thermal potential as the temperature responsible for heat transfer. Can I think where heat transfer cannot take place? What is that potential where heat transfer responsibility is not at all? This is 25 degrees centigrade. This is 0 degree centigrade. We can have temperature below 0, lower temperatures. At 0, heat transfer can take place. In the true sense, how to define a temperature which in the true sense we can call as absolute 0, where there is no heat transfer. Now if you see from the microscopic point of view, what is temperature? When we talk with respect to the molecules, the average kinetic energy of the molecules is the measure of temperature. Molecules are moving with more velocity shall mean exerting higher temperature. And as per kinetic theory of gases, molecules are always in the state of motion, however small the motion may be. That means some temperature is always there, however small it may be. When we talk of average kinetic energy of the molecules, we can say when the molecules are dead. They are never dead, but ideally, let us imagine molecules are dead, there is no kinetic energy. Temperature is absolute zero. Zero means no heat transfer. And that temperature is called as absolute zero. This measurement was done by Mr. Kelvin, and with the help of Celsius and Kelvin, they studied statistical thermodynamics and could arrive at the result that this 0 degree centigrade happens to be 273.15 degrees above absolute zero. So, what is this 25 degrees centigrade? When we start from absolute zero, this shall become 298.15, and then we will write Kelvin, because this idea was propagated by Mr. Kelvin. As read with the help of the thermometer, temperature indicated 25 degrees Celsius. For all our calculation purposes, as we use absolute pressure, same way we will be using absolute temperature, and that shall be called in terms of Kelvin. I hope here also the concept of absolute zero is to be used. So in all our observations, the temperature shall be given in terms of Celsius or centigrade, but for all our calculation purposes, we will be using absolute temperature in terms of Kelvin. Now friends, we have studied the basic terminology used in thermodynamics. Now we have to deal with the gases. For the interactions of the molecules undergoing various processes, getting work done, heat transfer, so on and so forth. First we will develop the concept for an ideal gas, and then will go in for the real gases. Very frequently in the interviews, question asked is, what is an ideal gas? And student says, the gas that follows. Ideal things is ideal gas. The gas which is pure, not impure, it is an ideal gas. What is expected from you? First, any gas that satisfies the relation PV is equal to N or T, or PV is equal to M or T, can be defined as an ideal gas. So long as the mathematics is concerned, it is okay. But in our mind, he asks, what do you feel about ideal? What is ideal in it? Then the answer would be gas comprises of molecules which are spherical in nature. They are having elastic collisions with the walls of the container. Elastic collision will mean it is frictionless. There is no loss of energy. The velocity with which it strikes, with the same velocity it gets rebounded. Molecular attractive forces are neglected. Practically, each molecule is being attracted by the other molecule. That will hold good for our real gases, practical in nature. When we are talking of an ideal gas, the molecular attractive forces are neglected. Between the two molecules, we are having a free path, and the volume of that free path is much higher than the diameter of the molecules. Now, I have used the term PV is equal to N or T, an ideal gas equation. We have studied about P, V and T. Now what is N and R? N stands for the number of moles or kg moles. Now the question arises, what is a mole? This term is very frequently used by chemical engineers, very rarely used for mechanical engineers. The chemical engineers are always using the term, but many times if the question is asked, what is a mole? It becomes a little difficult. And then if I ask a student, why don't you remember it? He says, sir, the thing is so simple that we have been using it, I know it, but I cannot express it. But my dear students, if you cannot express, you cannot be selected. One method is that you appear in the exam, get marks, get qualified, go for interview. There are very, very few companies who do not conduct the interviews. On the basis of the test they select. But for which candidates? For first 10 position holders in any area, whether it is chemical, it is electrical or electronics or computer, they get straight away selected and straight away the offers are given by the companies. Because they know that first 10 position holders, they are 100% clear about their subjects. And rest of the students, they are subjected to interviews. For this, we have to go back to our physics and chemistry. Avogadro's hypothesis. All gases contain equal number of molecules in a given volume at NTP. At normal temperature and pressure in a given volume, all gases shall have equal number of molecules. 6.023 into 10 raised to the power 23 number of molecules in a given mole. When we use the term mole, we mean it is gram mole only. And if it is 6.023 into 10 raised to power 26, then it becomes kg mole. What is that given volume? 22.4167. This will mean in terms of liters, and here it shall mean in terms of cubic meter. And what shall be the mass? Mass shall be equal to the molecular mass. In a given system with this volume, these number of molecules shall have the mass equal to the molecular mass, then it shall be called as 1 gram mole. Gram to kilogram 1000 times, number of molecules 1000 times. And this value of R, this equation invariably holds good for all the gases. We say this is a perfect gas equation, universal gas equation, and this R is called as universal gas constant. This equation PV is equal to M or T, where M shall mean the mass of the gas. And for a given mass of the gas, pressure, volume and temperature connected by this equation, this R value shall be for that gas only and is called as specific gas constant, which shall mean the universal gas constant divided by the molecular mass. For example, I want specific gas constant for oxygen or for oxygen. Universal gas constant is 8.3143 and molecular mass, what are the units? For oxygen, 32. Further, I have seen, if I ask the student what is molecular mass of oxygen, he says 32. But what is 32? What is the unit of 32? It is gram per gram mole or kg per kg mole. And what is the unit of universal gas constant? It is joule or kilojoule per kg mole Kelvin. So that kg mole and kg mole shall get cancelled and I will be getting the result in terms of kilojoule per kg Kelvin. Now let us see, have we written this value properly? I wanted to have the unit for this universal gas constant, which is PV upon NT. Pressure in kilonewton per meter square, volume in cubic meter, and the number of kg mole, temperature in Kelvin. This becomes kilonewton meter, that means kilojoule per kg mole Kelvin. Or we write in terms of, chemical engineers normally write joule per mole Kelvin. If you write in terms of kilo, then it will become kilojoule per kg mole Kelvin. So friends, this equation PV is equal to nRT, we should be very clear about their units. And each term which we are using, we must be able to define it properly. I hope things are simple. Any question? Now friends, after talking about the ideal gas equation, which is further to be used for the evaluation of the two energies, work and heat, in thermodynamics. So finally, let us try to define work and heat. First, let us take work. Question asked normally in the interviews, how do you define work done? How do you feel whether work is involved in the given system or not? My observations are, normally a student defines work as the product of force and displacement. Any student who tries to define force and displacement, I give him 0. Because the force and displacement may not be in the same direction. If this is a body, force F is applied and this body gets displaced by this distance. This is not F into X. So saying force into displacement is not correct. What we should do, we should try to resolve this force in the direction of displacement. So we should say it is a product of force and displacement provided both of them are in the same direction. It should become f cos theta, since in the horizontal direction theta is 0, cos 0 is 1, it will become f into x. Then force and displacement, both of them happen to be in the same direction. How about the units? Force is written in terms of Newton, displacement is in terms of meter. As earlier I told you, when science was not developed properly, anything you express, you used to become famous. This 1 Newton force displacing by 1 meter, this concept was given by Mr. Joule, and this is known as 1 Joule. Now, this is not enough. If I am having a battery I am supplying a current to a motor, and to the motor shaft a fan is mounted. When I switch on the battery, motor shaft moves, mechanical energy is obtained, blade is moving. I am interested to get work done. I am interested to talk about force as well as displacement. Can you visualize where is the force? Can you visualize where is the displacement? You will say yes, work is there, but you define work as a product of force and displacement. Neither force you can see, neither the displacement. So what should be done? We have to develop the concept, what is work? Whether work is involved or not. What should I do? This is the motor, this is the shaft. My mind says that somehow I should be able to see force. I should be able to see the displacement. Then all of a sudden I feel in my mind that weight term that we use is nothing but the force with which the body is being attracted towards the earth. That means simply I should try to have a weight. So over this shaft with the help of a rope, I put some weight. So I feel happy in my mind that I have been able to see force. Now the displacement. When you supply the current, shaft moves, thereby the weight is lifted up. And say in a given interval of time, this is the position of the weight. So I feel happy in my mind that I have been able to see force and I have been able to see the displacement. And product of force and displacement gives me the work done. So, my dear friends, I wanted to analyze in this motor whether the work was involved or not. This was my system. I couldn't analyze the system with that, so what I did, same system, I tried to have force and displacement outside the boundaries of the system. That means I have reduced the given system to an equivalent system where the force external to the system was used to lift this weight up. Or I don't supply the current, weight is here, I remove the table, weight gets lowered. That means again work is there, it is a product of force and displacement. Earlier the work was coming out of the system, now work is entering into the system. When work enters into this, no longer it acts as motor, it will act as generator, where work energy will be getting converted to electrical energy. Earlier electrical energy was getting converted into mechanical energy. Earlier the work was leaving the system, now the work is entering into the system. So, finally, how do I conclude? Work is said to be involved in the given system when the sole effect external to the system can be the weight being raised or lowered. Can be reduced to the weight being raised or lowered. Will come across many situations where neither force nor displacement. We have to resolve that system where the sole effect means the net effect, where external to the system. Because if I say this was battery and motor, what is the work done? 0. Here what is the work done? 0. Now how do you understand this? During the course of my lecture, I keep on moving in the class, well within the system. My movements are not recognized by the students. They say that teacher is well within the academic system. The moment I cross the boundaries and go outside, the students feel that a teacher has gone out. The management feels teacher has come out. The effect is external to the system, whether teacher is in or out. So long as I keep on moving well within the system, work done is well within the system, that work done is not to be accounted for. When shall work be accounted for? When the effect is external to the system. So this concept is very important. When the sole effect external to the system can be reduced to the weight being raised or lowered. So friends, today we finish it here, and then tomorrow we'll be developing a general expression for work done in any process. During this last portion, if there is any difficulty, you may ask.
So students are asking about the book, they can refer if it is required.
Friends, whatever book you studied earlier, that is the best book. Because you remember few definitions, you have solved few problems. Those who are interested to have another book on thermodynamics, amongst the Indian authors, Dr. Kumar is a very good book. Dr. C.P. Arora from IIT Delhi is a very good book. Professor P.L. Balani from Delhi College of Engineering is a very good book. Out of all, if you see, the best book available in the subject is by Van Wylen. Most of these books are the true copies of this Van Wylen. Otherwise, I feel whatever book you are having plus supplemented by me, which is the combination of around 25 books which I studied as a student or as a teacher. This is the gist out of that. Thank you. क्योंकि उसमें 20-25
Hello guys, I hope you enjoyed the class, and thankfully sir will be available to us, and he will come tomorrow again, and the schedule will be same most probably, otherwise you can check. And today you will have your weekly interaction meeting over Zoom just after your second class, and the link will be provided to you guys. So if anyone doesn't get the link over the WhatsApp, then you can call on the number of Lalaji or Jyoti to get the link. Thank you guys. And your doubt, I have noted your doubt, Sarthak. We will discuss that in next class. Okay? Thank you. I don't know guys about your empty class, वो तुम अपने फैकल्टी से पूछ लो ग्रुप पर, वो है अवेलेबल, और मैं बोल देना अगर लेट करनी हो तो.